Assalamualaikum. Welcome back to Circuit, Labs Physics and Chemistry video tutorial for high school students. In today's episode, we revisit static and dynamic equilibrium problem involving a rigid body moving with a constant speed up a rough inclined plane. How do we compute the coefficient of kinetic friction in this situation? Find out by hanging around till the end of this video. Watch and learn. The question is, a 250 Newton force is directed horizontally as shown in the figure to push a 29 kilogram box up an inclined plane at a constant speed. Question is, determine the magnitude of the normal force F sub n and the coefficient of kinetic friction U sub k. For our solution, we first identify the forces acting on the box. We define the x and the y coordinates such that the x-axis is along the surface of the incline and the y-axis is perpendicular to the surface of the incline. We represent the box as a point or a particle with the symbol or the dot symbol here. All right. The applied force F is represented by the vector arrow pointing to the right. And this force F forms an angle of 27 degrees, all right, below the positive x-axis. And its x component, labeled fx, okay, can be expressed as the product of the force F, or 250 newtons, times the cosine of the angle 27 degrees. That is, the x component of F is equal to 220 newtons and is directed into the positive x direction or up the incline. Its y component, right, denoted here by f sub y, is represented by this red arrow pointing into the negative y-axis. And it's just equal to the force F, 250 newtons, multiplied by the sine of the angle 27 degrees, which is equal to 110 newtons. Again, the direction of Fy is into the negative y-axis. The gravitational force, or the weight of the box, mg, is represented by the downward vector arrow labeled W. It forms the same angle of 27 degrees from the negative y-axis. This weight W, or mg, right, is equal to the mass, 29 kilograms, multiplied by the acceleration due to gravity, 9.8 meters per second squared. So the weight of the box is equal to 280 newtons. So the weight W also has its x component, right, represented by the arrow labeled Wx and is directed down the incline or into the negative x direction. So the magnitude of W sub x equals 280 newtons multiplied by sine of the angle 27 degrees, right? It is sine because uh, the x component of the weight W happens to be the opposite side of the angle 27 degrees, right? So with the help of your calculator, the magnitude of Wx is 130 newtons. Likewise, its y component, all right, labeled W sub y and is represented here by the red arrow or by the gray arrow, right, which is pointing into the negative y-axis. And its magnitude, of course, is equal to the weight, 280 newtons, multiplied by cosine of the angle 27 degrees, which is equal to 250 newtons. The force exerted by the surface of the incline, all right, uh, is represented here by the arrow pointing into the positive y direction, right? So this is normally called the normal force, right? The normal force, which means it is the force exerted by the surface, all right, perpendicular to the surface. That's why it's called normal force. And since the surface of the incline is not smooth, all right, so there is an opposing force when the box is moving up the incline, all right, there is an opposing force known as kinetic friction. And the force Fk, also known as the force of kinetic friction, is represented here by the vector arrow pointing into the negative x-axis or down the incline labeled Fk. Right. So, for our first target variable, which is the normal force Fn, all right, we apply the first law of Newton, or the law of static equilibrium, which mathematically can be expressed as the sum of all the vertical forces or all the forces acting along the y, denoted by F sub y, right? And uh, this summation of forces is just equal to the vector sum of the normal force, uh, the component of the weight W sub y, and the component of the force F, right? F normal is directed into the positive y-axis, hence it's positive. W sub y is directed into the negative y-axis, all right? That's why we use here the minus sign. And likewise, the y component of F, which is Fy, and directed also into the negative y-axis, hence the minus sign. So when these three forces are added vectorially, their sum must be equal to 0. That means the box is vertically at rest, right? So from this equation, we can isolate the normal force Fn and come up with the working formula to find the normal force Fn. It's just equal to the sum of W sub y and F sub y. That is 250 newtons plus 110 newtons. So, the normal force has a magnitude of 360 newtons. And moving on to question letter B, or finding the coefficient of kinetic friction, we also applied the law of dynamic equilibrium. All right? The problem states that the box is moving at constant speed up the incline. So that means the sum of all the forces along the x-axis must also be equal to 0. All right? So mathematically, the summation of fx equals the vector sum of fx, wx, and f sub k. Since fx is directed up the incline, so it has a positive sign, while wx and fk are both directed down the incline, so each one has a negative sign. All right? And the vector sum of these forces is equated to 0. That means we can again isolate fk and come up with its working formula. Fk therefore is equal to Fx minus Wx. That is, Fk equals 220 newtons. All right, this is the value of Fx minus, all right, the value of W of x, which is 130 newtons. So we get as the magnitude of the force of kinetic friction equal to 90 point Newton, emphasizing that there are two significant figures. So finally, we can now determine the coefficient of kinetic friction, right? Simply using the formula mu k is equal to Fk divided by the normal force, or that is 90 point Newton divided by 360 newtons. All right, so doing our math, we finally arrive at the value of the coefficient of kinetic friction equal to 0.30 in two significant figures. So that concludes our video lesson. Till the next episode, mabuhay, mashallah. Thank you very much for your indulgence. Please don't forget to subscribe to my YouTube channel.